In this video, we're going to look at how to find the inverse of a function given its equation. And the steps are, number one, we replace f of x with y. Number two, you switch x and y because that's a general definition of the inverse of a function is to switch x with y. And number three, we solve for y. And then that will find f of x. So f inverse of x. So number four, you replace the y with f inverse of x. So in this first example, we're looking for the inverse of g of x. So we are actually looking for g inverse of x, and that's how you read this notation. The little -1 is not really an exponent, it's just read g inverse of x. So we are looking for g inverse of x. To find that, we're going to follow these three steps. So step number one, we are going to replace the g of x, in this case, with a y. So instead of g of x, we'll have y equals 3x plus 4. And then step two, we're going to swap x and y. So in other words, the y is going to become an x, and then the x is going to become a y. So we swap the x and the y. So we get this equation, and then step three says to solve for y. So that means we need to get y by itself on one side of the equals. So since x is already by itself, we're going to leave that side alone, but we want to isolate this y. To do that, first of all, we want to get rid of the adding 4 by subtracting 4 from both sides. What that will do on this side is cancel the 4's on the right side and leave us with just 3y on the right. On the left side, x minus 4 is just x minus 4. And then now to isolate the y on the right side, we need to get rid of the multiplying by 3. The inverse, or the opposite of multiplying by 3, is dividing by 3. So you notice that we are doing opposite or inverse operations. That's the idea. To find the inverse of an equation, use inverse operations. And you switch x and y and use inverse operations. And what that will do is that will isolate our y, and that will give us x minus 4 all over 3. That cannot be simplified, so we will leave that fraction just like it is. And now we have y by itself. Once you get y by itself, you have found g inverse of x. It is x minus 4 all divided by 3. And that's your answer. So it's a really simple process. It's basically just solving equations, but first you have to switch x and y to solve the equation, and you're solving for y. So let's look at number two. Number two has a fraction in it, so we got to go back and remember how to solve equations with fractions. First step, though, number one, is to replace the f of x with the y. So we're looking at y equals x over 2 minus 6. And then our goal is to find f inverse of x. So that's three steps. First we get x by itself. First we replace the f of x with a y. Next is the most important step. We swap x and y. So we're going to let y be x. So we'll have x equals, and let x be y over 2 minus 6. And then here now we need to isolate this y on the right side. To do that, we need to get rid of our fraction first. You always get rid of fractions by multiplying every term by the LCD, or the least common denominator. In this case, our three denominators are 1, 2, and 1. Our least common denominator then would be our biggest denominator, which is 2. And we're going to multiply every numerator then by 2. So 2 here, 2 here, and 2 here. So notice that we're doing the opposite of dividing by 2. That's what least common denominator does. It's the inverse of dividing by 2. And when we do that, on the left side, you just have 2 times x. On the right side, this denominator will cancel with that numerator, and we have got y by itself. And then here we have negative 6 times 2, which is negative 12. Once you've cleared the fraction, then the only thing left to do to get y by itself is to get rid of that minus 12. To get rid of minus 12, you add 12 to both sides. So we'll do plus 12 and plus 12. Since 2x and 12 are not like terms, we will just write this out as 2x plus 12 equals y. And now that y is by itself, we have found f inverse of x. It is 2x plus 12. So let's look at example 3. Example 3 is h of x, so we are looking for h inverse of x. And to find that, first of all, we're going to write h of x as y. So we'll have y equals x to the third plus 2. And then, of course, inverse means to switch your x and y. So we'll have x equals y to the third plus 2. And then now we need to get rid of the 2 in the third power. Well, the first thing we're going to do is get rid of the minus 2 to get rid of, plus 2. To get rid of plus 2, you subtract 2 from both sides. That will leave us on the left side with x minus 2 equals y to the third. And just like we learned with square roots and squares, the inverse of a power is a root. So the inverse of a third power, instead of being the square root, would be the third root. So if we want to cancel this third power here, we need to take the third root, or the cubed root, of y to the third. So powers and roots cancel each other, just like multiplying by 2 and dividing by 2 cancels each other, or adding 2 and subtracting 2 cancels each other. Y to the third and the third root cancels each other, but don't forget, whatever you do to one side, you have to do to the other side. So I took the third root of both sides of this equation. On the right side, what happens is these two cancel, and we get y by itself. So a root and a power will cancel each other. On the left side, I don't know what the third root of x minus 2 is, but that doesn't matter because I have found my answer because y is by itself. And so h inverse of x is the third root of x minus 2. So let's look at example 4. Example 4 has a third root in it. And remember, roots and powers are inverses of each other. So let's try this one. First, we're going to let h of x be y. So we'll have y equals the third root of x plus 1 minus 5. Then we're going to switch our x and y. So we'll have x equals the third root of y plus 1 minus 5. So eventually we're going to have to get rid of this third root, but notice that this minus 5 is not underneath the root, so the first thing we can do is we can get rid of this minus 5 by adding 5 to both sides of this equation. So we can only do that because that 5 is not part of the cubed root. So we can add 5 to both sides, but notice this plus 1 is underneath the cubed root. So I've got to get rid of the cubed root first before I can get rid of that plus 1. So to get rid of a root, you raise it to a power. So to get rid of a square root, you'd raise it to a second power. To get rid of a third root, you'd raise it to a third power, and so on. So in this case, we want to get rid of a third root. So we're going to take the third root of whatever and raise it to the third power. But whatever you do to one side, you have to do the entire other side. Okay? And so what will happen is over on this side, the root and the power will cancel each other on the right side, and I'll be left with y plus 1. On the left side, I have x plus 5 to the third power. And I'm not going to try to multiply that out because remember, my goal is to just get y by itself. And there's only one more step here to get y by itself. You subtract the 1. And that 1 is not underneath that third power, so I can't subtract it from that 5. So I would have to write my answer as x plus 5 to the third power minus 1 equals y. So my h inverse of x is x plus 5 to the third power minus 1.